What's up everyone? In this issue of Platinum Tech, we are comparing Nissan's legendary RB engines using real data and facts rather than rumours and myths. Let's go.
Nissan's legendary RB series of engines are one of the most popular in the tuning scene. With a few different ones in the lineup, there are plenty of internet rumours and hearsay about the differences between the blocks and which one is better. But there's not a lot of hard data. Well, we're about to change that. We're not here to say which one is the best or analyse Nissan's design, just merely give you the data and facts to help you make up your own mind. Herman from Platinum Racing Products has been performing both non-destructive and destructive tests on various RB blocks over the last couple of years to help with development of engine braces and also test blocks for customers and give full reports. He has tested well over 300 blocks in the last 12 months alone, so has a large range of data to work out the averages. First up, let's take a physical look at the differences between the RB blocks we have assembled and compare them. The benchmark is the RB2605U block found in the Skyline GTR. Its design isn't perfect and known for poor oil control that needs to be addressed, but we've personally proven it can handle almost 1,000 engine horsepower. However, the block is proven to crack above 650 wheel horsepower, usually between cylinder 3 and 4 above the turbo oil feed. You can see that this area is quite thin in material and close to the bottom of a head stud. The cracking has to do with engine twist, which has a lot to do with the engine having a front differential attached to it. As you can imagine, a bunch of hard launches puts a lot of strain on the block. However, cracking here doesn't affect the engine performance, and many owners continue to drive their cars with it simply by covering the crack with some JB Weld. Consider it a rite of passage of GTR ownership. We've done it and there was no issues. The first block to compare is the RB25 block. You can tell the difference between a two-wheel drive and four-wheel drive RB25 block by the row of bolt holes on the bottom of the block. The four-wheel drive has two lots of bolt holes, the same as the RB26, to suit an all-wheel drive sump. Looking over the RB25 block, the only difference we could see on the outside is the lack of the oil drain at the bottom and instead another one on the side. Up top, the RB25 has two oil feeds to the head. The 26 actually has two as well, but one of them is blocked from factory. The RB25 also has another oil feed for the variable cam timing up the front, and the water cooling journal is slightly different. These need to be modified to work with the RB26 head. The next difference is that the RB25 uses 11mm head studs compared to 12mm in the RB26. And lastly, the NOx sensor threads are slightly different. Overall, it's nothing that a machine shop can't sort out for you to use a 26 head on a 25. Next, the 24U RB26 block, also known as the N1 block, found in N1 models and a few special editions of the R34 GTR. It was also sold by Nissan as a bare block to both race teams and the public. It has been the go-to upgrade for GTR owners for many years, but still a lot of myths and hearsay surround this block. No one seems to be able to get a straight answer out of Nissan either. It's rumoured to have more nickel content and to be a harder block, as well as having revised cooling galleries, and some say reinforcement inside to stop twisting. How much of that is true, we don't know without cutting the block open, but we can say that we couldn't find a single difference visible to the human eye, not inside the block or externally. The N1 block was made in two different batches. The second is a different foundry and with a different exterior finish that is smooth seen here. Moving to the 3-litre blocks, you can see the capacity difference comes from a taller block height, just under 40mm. But notice the water pump is in the same spot relative to the bottom of the block. The water pumps and oil pumps are interchangeable on all RB engines. The RB30 also doesn't have oil squirters. Probably not vital on a drag or street car on E85, but something to consider for circuit racing. Some say this extra height, which adds more material, is what helps make an RB30 block stronger than an RB26 and less prone to cracking due to twisting forces. The fact that the bottom of the head stud is further away from the area prone to cracking on the RB26 could also help. You can see there is more distance between the Welsh plugs. Now moving to the RD28, which starts life as a diesel engine. Looking at the block itself, the design externally is different and appears to have more material below the Welsh plugs, so there is no external ribbing visible. Looking inside the engine, the RD28 has added ribbing running up the inside of the block below the bores. The RD28 also has more material between the block and the main caps. It's clear that Nissan wanted to increase block integrity and stop block twist with the RD28. The extra material should equate to more weight, which we will test later in the video. The RD28 uses 12mm head studs, the same as the RB26, and visually you can see the RD28 has a thicker deck, but we will measure just how thicker it is later in the video. The RD28 does have different oil and water galleries on top of the deck that need to be modified to fit the RB26 head. We're not here to give away workshop secrets or show you how to build an engine, but a good machine shop and engine builder know what to do. The RD28 also differs by having 85mm bores instead of 86mm bores like the other RBs. All of the visual evidence points to the RD28 being the ultimate block. But is it? Only hard data will show the entire truth.
Started looking at non-destructive testing of RB engines a couple of years ago. I kept going to the big rigs of the industry trying to work out what made a good block. I was testing blocks in engines, cracking them, not being able to work out what actually makes it better. So after I asked everyone that I could possibly think of, including guys in Japan, what made one block better than the other, no one actually knew was the answer. So I thought, this is just not good enough. I went and saw a metallurgist friend of mine and we sat down and went through what makes one block better than the other. It turns out that hardness and sonic testing the bores is the only things that matter. It doesn't matter whether it's an early model, high nickel, it's got extra guzzeting. Obviously our platinum brace stops the block twist, so extra guzzeting that Nissan did put in blocks to eliminate the block twist, we've overcome with an aftermarket brace. And all it really comes down to then is bore thickness, because your bore's going to crack whether it likes it or not, being too thin. So you want to maintain over about 3mm is my benchmark minimum for a bore thickness. And you want to stop the bores ballooning, and the only thing that will help is a harder casting. So whether the block was cooled quickly whilst it was being manufactured will lead to a harder block. If it was left in the cast over the weekend on a Friday, for example, it's going to be a pretty poor quality block. And everything else, as far as I'm concerned, doesn't matter. So I use a non-destructive testing, obviously. I have a little hardness testing machine. It bounces a ball bearing and measures the frequency, basically. This is a sonic tester. It's the one I choose. It's a dual crystal version. You don't want to go and compare one hardness test to another. As long as you're using the same piece of equipment and it's calibrated, that's all you need to worry about. I like to hardness test blocks in the same spot on all of them, just to give me some consistency. Okay, so now we're going to go through and test all the blocks that Andrew's gone through previously. This is unedited, uncut footage, so you're going to have to bear with me a few mistakes here and there. This first block is an RB26 block. It's an 05U. It's the most common block. They usually test around the 240 to 250 mark on my equipment. So I take an average of 5 tests here, which I do right here in this spot here. So we're just basically bouncing the ball bearing and we're measuring its frequency. That measures at 236. So that's slightly, it's average, slightly below average, I'd say, for an 05U anyway. Next block. RB25. So this is a 23U block from memory. These usually test up the same as an RB26 05U. There's not much difference. The blocks are very similar, as Andrew's described for you in the previous video. And we're just going to run this one. Okay, average of those 5, 251. So I'd say that's average or slightly above average for a 23U RB25 block. In this particular case, it tested up better than our 05U. Luck of the draw. Next one up is an RB30. Now these things always test up better than the average 23 or 25, 05U block. They're just a stiffer block. They're really good quality casting. Find that usually they'll average between 250 and 270 odd, with the odd unicorn that you get up around the 280 mark. That doesn't happen very often. I'd say a 260 and above, great block. $277. That is extreme high range quality block. That's as good as you're going to get. Probably go through, I'd say 30, 40 blocks to get one that quality. So that's a good one. RD28 is our next block. Now these things usually test pretty poorly, 220, 230. So we'll see how it goes. $257, which is extremely good for an RD28. I'd call that a really good quality block. Okay, now the last one, and we've kept this one to last for a very good reason, is my favourite. Not because it's any good, it's because it's usually pretty bad. It's the N1. This is the Series 2 late model N1 block, 24U. They're not my favourite block. I've been bagging them out for years, and I think you're about to find out why. $240, which is still pretty good for an N1, and as you can see, it's no better than any other block we've got here. In fact, it rates in the same range as the 05U and the RB25 four-wheel drive block. So from this point of view, it's not any better. Next bit, which is the most crucial test of all, I'd call sonic testing. So we basically measure the thickness of the bore. We find out where it's strong, and if it's got any weak spots, we can offset bore away from that weak spot to capitalise on the thicker part of the bore. So if you've got a bore, for example, that is 3.5 mil on one edge and 6 mil on the other, you'll offset bore it and just touch the 3.5 mil side to keep that integrity and chomp away at the 6 mil, you've got heaps of meat there. So you can effectively pull the difference between an average block and make it a good block after you machine it, because you've got that material strength there. So debunking is thickness of bore material in all of these blocks. There is not one any better than any other. For example, N1 is not any thicker than a standard 05U or 23U or RD28. The only difference is with the 28, it starts off being an 85 mil piston, so there's usually an extra half mil in each wall section. But once you machine it out to 86 or 86.5 for your off-the-shelf type piston, it becomes the same as any other block, for example. We're going to start with the RB26 here, and I'm just going to sonic test the first cylinder and show you the difference between the front wall, the back wall, and the thrust. Thrust is usually 4.5 mil to around about 6.5 mil. So I'll just quickly throw some sonic fluid on there. And we're going to get a good contact here. I don't know if you can see the actual result there, but on the left I've got the little lines that show you've got a good contact. 5.7 on the thrust, really good. So let's put that there. Then we're going to go and measure the front wall. 5.6, awesome block so far. Now I usually measure at least 20 datum points in every bore, and as soon as I start finding something a little bit thin, I'll go and explore that area to mark down the findings as in worst case scenario. So I'll only write down worst case scenario on each face. Although I might have tested 30 different spots on the face, you write down the worst because that's the only one that matters. Okay, 4.4, 4.6, hang on, I'm trying to get really good contact there, it should stabilise. Okay, 4.2 millimetres on the back wall. That's a really good bore. Now, the back wall usually gets thinner and the front wall, for example, if the front wall is thicker, the back wall will be compromised. It'll be thinner. So if usually I find a 5.5 mil front wall, the back wall would probably be closer to 3 mil. I'm not so worried about a thin bore down the bottom because there's no cylinder pressure down there. So if I've got 3 mil down the bottom, not too worried. 3 mil up the top, I'm starting to get stressed. So far, I mean, I've only tested 4 points. So if the block was consistently that thick across the whole range, I'd say it's an extremely good block, well above average. Seeing that this particular RB26 block is above average, I'd say this 25 won't be as good. But then again, we're only pulling one sample off one of the bores. We could get to the 5th cylinder and find that it's 2 mil and condemn it. But let's have a look. .2, really good. We're going to check the thrust now. Okay, really good thrust. 5.7. Let's check this front face here. 3.96. I'd still call that pretty good bore. If we go back to the back, we had 4.2. You might offset a little bit, it's really not going to make that much difference. If you were trying to get away from a 3 mil bore, wall thickness, sure, you'd go and take advantage of that extra little bit of meat. All right, so we're going to go and test an RB30 now. I'm going to test fairly high up in the bore just because I can't get my hands in there. 4.3. Check the thrust. I'm expecting a good thrust on this. 5.8, pretty good. Let's go and check the front face here. 4.8, pretty good block so far. Back walls, as in the inlet side, the opposite of the thrust, they're usually really good. So we won't spend too much time there. I'm going to test the back wall on this one. 4.1 mil. Let's go with thrust side. Awesome. Near on 6 mil. Oh, hang on a second there. Oh, here we've got a problem. 3.1 mil. Now, my limit's 3 mil. So here, if you didn't offset bore this particular job and you took a mil out of it or half a mil at 86.5 and you went into that front face, I'd call that pretty dangerous. They are always random across the board. You'd never know what you're going to... You can't leave a particular part of the bore untouched because you never know what you're going to get. So you really do need to spend the time in each bore to work out where the thinnest part is, and then you can start to build a report. So far, this one goes to show we're getting pretty thin on the front face of cylinder 2 there. It's up the top where it's getting thin, just over 3 mil. An offset bore will save that block. You can still handle a lot of boost and high power racing application, but you go and bore it willy-nilly because you didn't do any testing and all of a sudden you've got a crack bore. The RD28, the myth is that it's got a really thick bore, but once you remove that millimetre or 2, so you're going to go to an 86.5 and take 1.5 mil off that overall, so call it 0.75 of a mil, you might not be left with that much meat. So let's go and test the back face because we've been testing the back. Okay, so that's around 4 mil after we take that first cut to an 86 bore. 86.5, I should say. So pretty average. I mean, it's probably a millimetre, half a mil under some of those other ones. Nothing special, yeah? 6 mil, take 0.75 off. We're still around average in the 5s. Okay, 5.8. We're back down to around the 5 mil after we take that oversized cut out. So there's not that much different with an RD28. The way you get an advantage with this is to run an 85 mil piston or an 85.5 or 85.2 or whatever you can get away with. Custom piston, that way you gain that extra mil, and yeah, it makes a massive difference. The difference between 4.5 and 5.5 mil, for example, huge. So that's the way you'd handle it. If you were gonna go RD28, that's the only reason I'd recommend running the RD28 is for the smaller piston. All right, we're leaving the best to last here. My favorite, the RB26N1 24U block. Nothing special with the bores. I've tested dozens of them, but we'll have a look at this one. Straight away, we got 3.2 mil. That's scary, that's below average, and a half mil out of that. Well, it's going to be 2.25 we're taking out of that. We're right on my limit. If you didn't offset bore that, I'd say you're risking a cracked bore already. That's not to say the rest of the bores aren't better or worse, it's just the first reading I've taken. Thrust, great, 6.1 mil, nothing wrong there. Now, because the back is thin, I'd expect the front to be thicker, which it is, 5.5 mil, really strong for the front. So we can get away, we've got more than enough meat to offset bore that towards the front and leave the structural integrity on the back of that bore and save this block. Okay, so now we're gonna measure the thickness of the deck. I don't think that the major issue that concerns an RB is deck thickness, it's cracking of the bores. If you're not over tightening your head studs and you're keeping your cylinder pressure down for whatever reason, it's not going to be such an issue. You want to maintain, strengthen the bores. But we are going to measure the deck thickness because it can be a contributing factor, and you'll see how much they vary and the difference between all the RBs as opposed to the RD block. Okay, so there's a few ways to measure the deck thickness of the block. We used a micrometer. You can use a vernier, as I'm about to show you, or a sonic tester. So we pulled 10 datum points off each block to grab an average with a mechanical measurement, and now we're going to run through, show you how to take a mechanical measurement with the simpler version, vernier, and then I'll pop through with a sonic tester and we'll come up with some findings at the end. I like to use an Allen key because you can hold it straight and take a measurement. You can keep them fairly well parallel. Other way to do it is to use a vernier and just drop it through the hole there and you get your height. So we're ready to roll on the RB26. Sonic testing in the same spot in all these blocks. We've got about 7.5 mil. This one averaged 7.66 mechanically. Now we're going to go over to the RB25. Quick sonic test in our datum point. We've got about 6.6 mil in that spot. This one mechanically tested an average of 7.4 millimeters. Now this block has been decked. The RB26 hasn't been, so 0.2 of a mil, rough. Can be a rough machining off for decking. Now we're moving over to the RB30. 7.1 mil. This one had a mechanical average of 7.7 millimeters. It doesn't look like it's been decked. Now we're going to move over to the RD28. $12.7. This one we had an average of 12.8 millimeters, I believe. So it's by far the thickest. It's a monster compared to all the others. My favorite, the N1. These ones are apparently a mil thicker, but you don't know until you test it, obviously. Sorry, I'm getting a proper reading there. 8.7 mil, and this one tested up mechanically at 8.66. I'd say it's fairly accurate because we don't have a lot of rust underneath that water jacket that's given us an undulated surface. So it's pretty accurate. Happy with these results. We're just going to weigh the difference between these blocks on some home scales, bathroom scales here. We're not really worried about splitting hairs. We just want to know what's got a heap more weight and what doesn't. 63.7 kilos. Okay, we're going to weigh the 25 block. I'm expecting it to be a kilo or two heavier because it's got bolts in it and the other one didn't. 66.6. My favourite, the N1, the almighty N1. It's supposed to be a heavier block because it's denser, right? And it's got extra water gallery material and it's got extra this, that and the other. Let's find out how much heavier it is. 67 kilos is what our RB26 weighs, roughly. And what's this? Oh, 66.6 kilos. That's consistent. It's actually identical to our RB25 over there. That's got the bolts. The RB26 didn't have bolts, so I'm going to say they're identical. Okay, now we're going to test the RB30. There's always a bunch of speculation around the traps that it weighs so much more and going to change the dynamics of your car because it's so heavy. It's got a taller block by about an inch, but the RB26 has got a much thicker pan rail, obviously, for the four-wheel drive setup. So let's weigh it and find out how much different it could possibly be. 68.8 kilos. It's 2 kilos heavier. Unbelievable, is it? It's nothing. Who cares? And now, the RD. Now, I know this thing's heavier. I move them about all the time, and it just slips that extra bit of disc every time I do it. So let's throw it on the scales and see how much I'm manhandling daily. $78.9. That's a good 10 kilos heavier. It feels like 10 kilos heavier as well. That's not negligible at all. That's a fair amount of weight. So the only difference after all that testing and stuffing around between the RB25, 6s and N1s is the N1 is by average a softer block, but it does have a mil more deck thickness to make up for that. So is it worth 10 times more? I don't need to give you my opinion. You've got the answers here.
So there you have it. The data is in. The bore thickness is pretty much the same and quite erratic between all blocks. We recommend that in any big build, you check the bore thickness to make sure none are under 3mm, and you can use the information to offset the bores. Using the RB26 as the benchmark, the four-wheel drive RB25 is essentially the same except for needing to be machined to accept larger head studs. Being cheaper to buy is probably offset by some extra machine work required. However, there are probably more stock RB25 engines around, or certainly ones that have led an easier life. The legendary N1 didn't weigh any more and is tested softer on average. The only real advantage we could measure is the thicker deck height. Once you add an engine brace to a standard block helping prevent twist, the extra deck height is all the N1 could offer, no matter what data, facts or rumours you go off. Then there is the extra price you pay for an N1. Is it worth it? Well, we'll leave that for you to decide. Moving to the 3-litre blocks, the RB30 comes up the winner when it comes to hardness. This, combined with extra block height and material, explains why it cracks less with big power applications. It does have smaller head studs though, but they can be easily machined out. It was interesting to note the RB30 is only 2 kilos heavier than the RB26, destroying the myth of the RB30 ruining weight distribution. However, the RD28 is a whopping 10 kilos heavier again, showing it indeed does have some more mass. More mass, combined with more bracing, thicker material in key areas, and more reinforcement inside the block and around the main journals, along with a much thicker deck, means the RD28 should really be the ultimate block. Its 85mm bore also means more scope to do some offset boring and get good wall thickness across all the cylinders. Bizarrely though, it tests softer than the RB30. Does this make it stronger or weaker overall? Does the extra mass make up for it? Well, we don't want to make the assumption, but if you're building a mega-powered RB, you are most likely adding an engine brace, grout and even billet main caps or integrated main cap and girdle. All these things make it hard to determine. Both blocks have been proven at the track in some of the quickest GTRs in the world. The RD28's extra deck height would help with strengthening the bore and help with sealing, so potentially it has the win in extreme high horsepower applications. Its downside is the cost of all the machine work required. Is it worth the money? Well, once again, we need to let you decide that. So when it comes to RBs, you now have the data and facts. Which one is right for your build? Well, price, availability and budget for the build will have a lot to do with it. We will finish with this though. Getting your block checked and measured before building is very important thanks to the inconsistencies found during manufacturing. You may have a preferred block, but if it comes up soft or has poor bore thickness, you're out of luck anyway. So, now that you know that you are looking for, it's time to go build an RB.